And here, that is not our focus to learn how to solve for this one, but here I want to give you the whole story. You solve equation 1 for the working functions and with certain the boundary conditions, okay? So once we solve this one, then we can have the stress. The stress, basically, this is the in this plane. This cross section is in the axial directions. So on this cross section, we have the stress components xx and xy and xz components. And because for this cross section it doesn't have any axial loading, so this is the normal stress in the cross section, which should be equal to 0. And on this cross section, the direction of the strain stress component, this is the tau xy and this is tau xz. So here we decompose the strain stress component into the xy and xz. So that is the information here. Once we have this function to solve, then we can calculate this strain stress. This is the function of this one, and that will be equal to g times I forgot that one. I forgot really the details. Something like this, okay, something like this. So that means the xy are the coordinates of any point. So here, basically, here is this. As long as you can identify any point, the point has a coordinate y and z on the cross section. So you can plug into here y and z. So you proceed to the derivative of this function, then you can completely set up the function, the stress function like this, okay? So by using this information, we will be able to calculate the stress components here. And with the stress components, then we take, the next step is we simply take the moment about the, say, the center of the cross section equal to 0. Then we'll be able to obtain, because the whole cross section has been twisted by a torsion, and that means we'll be able to get the relationship between the torque and the stress. Okay? So that is the whole solution process. And again, from how to obtain this formula, this equation, that will based upon the certain explanations, and that won't be here. And so if you take up those process, and this will be the result, relation between the torsion and this one. And once we have those things, then we'll be able to confirm to relate the torsion, because you can see the torsion, we will have a relation between the torsion and the stresses. The stresses basically is related to the angle of the twist. So basically, eventually, we will have the relation between the torsion and the angle of the twist for non-circular shaft. That is the thinking process, and then we can look at the our PowerPoint slides here.